Okay, we're going to get started here. Once again, welcome to Siewert Equipment's Mechanical Seal and Reliability Seminars, webinars. Today we're going to be talking about sealing needs for the pulp and paper industry. I am Frank Rotello, the Mechanical Seal and Reliability Engineer with Siewert Equipment in New York. Now let's get started. As you can see, this is a schematic of a pulp and paper mill. As you can tell, and I'm sure all of you that work in the pulp and paper industry know there are a lot of steps involved in the paper making process, right from the wood yard right out to the loading dock. I just wanted to give this as a quick overview. Maybe there's some people that are new to the industry that don't know exactly what's involved in the paper making process, but this is a quick overview of it, and I'm not going to get too much into the paper making process itself. I'm just going to get into what the sealing needs are, because I could spend quite a bit of time covering that. Now, system overview, we're going to talk about the fiber sources. Fibers which can be used in paper making process. Wood fibers from trees, recycled bags, rags, vegetable fibers, mineral fibers, and even synthetic fibers. The goals of a wood pulp production facility. One, we want to keep the cellulose fibers. We want to remove the lignins, and we want to produce evenly sized, well-divided fibers. There are three basic steps. We need to prepare the wood, separate the lignins from the cellulose, prepare the fibers for paper making. Wash, clean, bleach, refine, screen. Now, in this process, again, this is a gross overview of the process itself, but if whatever plant you're working at, you want to talk with your process engineers to show you how to take you through the whole process of it, you can get a good idea about how you can start understanding how everything fits together. We're going to talk about the seals used in your industry itself, specifically. First, there is the general service seals. This is the ISC II standard pusher seal. These are these are standard made to specific ANSI standards, so that they're readily available. They're stocked. They're generic sizes, and they can be turnaround times are very, very quick for these types of seals. You can see a single seal pusher seal in the top left-hand corner, and just below it is a dual version of the ISC II. Both are used in the pulp and paper industry. There are quite a few applications that can set up. There's tarring. There's especially with some of the black liquor products, you can get you need to have dual seals to be able to keep the stuff from setting up around the seal. And we'll go into that further with the different processes. But this is the standard general mechanical seal that's used in most general applications, and especially your ANSI pumps. The BX bellow seals. Now, the BX seals are used where you have places where you'd have polymerizing or crystallizing types of processes, things that would harden and set up around or hang up a dynamic O-ring. From some of the previous webinars that I've hosted, I've talked about the different seal designs like pusher seals and bellow seals. Well, the pusher seal, if you recall, has a dynamic O-ring which can hang up. The bellow seals do not. The bellow doesn't allow since you have a bellow, there's no contacting surface to the actual sleeve or shaft of your pump, so nothing can hang up. So bellow seals work very well in applications like that. They also work very, very well in high heat applications. You can take a bellow seal up to 700-800 degrees. It doesn't have very good pressure capabilities, but it can take extreme heat. So again, bellow seals have a place in the pulp and paper industry. Other types of seals here are the SLM and the SLC. Now, these are slurry style seals, and if you can see from the different cutaways that are in front of you, you'll notice in the top left, and I think you can see my cursor on this seal itself. If you'll notice for the green, that's the stationary face, and you'll see the red, and that's the rotating face. you'll notice how they're what they call end facing. Means that where those two seals meet, it's at the farthest most point, and there's no recessed step in the seal faces themselves. Some of them will have a wear nose. This does not. The reason there's no wear nose is because in slurries, you want to be able to expel away debris and solids away from the seal faces, and that's why the seal is set up the way it is. It's set up end facing and outer rotation, so that everything that can come in contact with the seal faces is thrown away. And that's basically the big factor with a slurry style seal. Other factors that you can see, the springs are actually outboard, designed very similar to the ISC2. The ISC2 utilizes this design. It's a very successful design for keeping springs out of dirty surfaces. It's also a very robust. Your slurry seals are generally thicker, heavier material, very durable seals. Thick O-ring grooves, thick O-rings. They're meant to be abused. Below it is this is an SLM dual seal. Now the SLM dual seal, and we'll talk a little bit about where these things, of course, are applied. This has a port, and you can see it here that goes in white. It goes right straight through what is the blue-colored gland. That port is for grease. This is a seal that you can use grease in the seal itself to actually act as a barrier fluid. There are automatic greasers that they make that they can put on here. Flowserve makes one itself. It's a lubricator. You put it on, it's battery operated, and it maintains the proper amount of grease in that area. And of course, the other mechanical seal used is the SLC. The SLC is the highest solid content mechanical seal made by, at least made by Flowserve. So it's an industry leader and can handle up to 60% solids in service. The SLC is the seal that takes the most abuse. It doesn't even have springs. The SLC actually has it's got a leaf spring, a wafer. That's in the front, and if you can see where my cursor is, that actually acts just like a leaf spring and keeps pressure against the seal faces to keep them closed. There's absolutely nothing that can clog that leaf spring. And again, you can also notice it has the end-facing design as well. Slurry seals, and you'll see when I start talking about the different applications where slurry seals fit into the pulp and paper industries. As some of you know, the pulp stock can be quite abrasive. Another application in some of the larger type vessels and larger pumps, especially vertical pumps, it may be very difficult to take that piece of equipment down to replace a mechanical seal, especially if you have to remove it off the shaft. So what they make, of course, is split seals, both for mixers, which is the MSS, and the PSS III, which is on the left-hand side. The PSS III is a unitized cartridge split mechanical seal, meaning that there's only 4 parts to the actual cartridge seal to put it together in a split configuration. You have one split half is the rotating part of the seal, which goes to the shaft, and then the second one is the split gland that goes onto the stuffing box. Those two pieces are the only pieces that need to come together to put the seal together. The PSS III it's a very unique design because it saves a tremendous amount of time from installing traditional type split seals, which have all of the O-rings and individual parts. The MSS is a mixer seal, a split seal. Not quite as unitized as the split seal, but again, in big large vessels that are it's going to be rather time consuming to disassemble and put a seal on, or when you want to get away from the leakages of packing and the added efficiency of a mechanical seal, they make the MSS split seal. In your boiler house, in the steam generation center, you'll have a lot of boiler feed applications. Some facilities have very small boiler feed pumps. Some of them have rather large boiler feed pumps. Some of the better designed mechanical seals here that Flowserve developed was called the QBU seal and the D Seal. The D Seal has been around for years. The D Seal is it's a single spring, very, very wide mechanical. The mechanical seal faces are very wide. It is a very, very tough, long-running, high-heat mechanical seal designed for boiler feed applications. It can take a lot of abuse. The QBU is a variation of the QB seal, which is an API seal. It's an oil and gas seal. This, the variation here is, if you can notice in the seal face the seal interface, where you have the yellow stationary face and then you have this orange rotating face, you'll notice that there's a small carrot. Looks like a little tiny mouth that's actually cut into the face. The QBU used to be called the QB lube. And what that meant is they called that the lube groove. When you have hot water, when it gets up, like I said, above 180 degrees, 170 degrees, it starts to lose its lubricating properties. Also, as soon as it gets to atmospheric pressures, it wants to turn into steam. With the U-lube, with the U groove on a lube seal, it acts as a buffer to increase the pressure and hold basically give you a little bit of changes the pressure gradient across the mechanical seal face. It allows for a pocket to keep the water vapor in there, maintain its consistency so that it doesn't flash off, and act as a pocket to keep the face lubricated and cool. It works very, very well, and it is a patented design by Flowserve. The best thing about this is up to 325 degrees, you need no cooling with your boiler feed application. So this seal could go into a boiler feed pump with a basic flush, a basic Plan 11 flush, to help suppress the vapor point, and it would run standalone up to 325 degrees in hot water. Very few standard mechanical seals can do that. That's one of the hallmarks of the QBU, and one of the things that's a very strong point. So when areas where you can't have cooling, you don't have room for a heat exchanger seal cooler, you don't have any cooling water to bring in, then something like this, or it's very expensive to bring in cooling water, something like this is a very, very good option, as long as it fits within the pump, because that's another important aspect. It's a very, very good good choice, and it solves a lot of problems very simply. If you can bring in some cooling, like for instance, if this is in a dual configuration and you were going to have a barrier in the back, a barrier system on your pump, and you wanted to cool it down, well, then you can take the temperatures up to 400 degrees, and this thing will still work. Now we're going to talk about the sealing applications, where all those mechanical seals that I just talked about, we're going to show you where these seals fit into your process. Okay, sealing black liquor. Weak to medium black liquor, that's 12 to 50% concentrate. We prefer dual seals with pressurized barrier systems, so the 53s, or even a 54, to prevent the liquor from setting up between the inboard faces. Again, this is what I was talking about in some of the bellows designs. If you're running single seals in situations like this, and the black liquor sets up, when you go to restart the pump, the faces are stuck together, components are frozen up, and you won't have a seal for very long. The ISC2 or double BX seals are preferred in these types of application. You want to make sure that you're using an AFLAS type O-ring or an EPR O-ring for your gaskets and elastomers. Vitons and Buna and any types of caustic surfaces do not work well. So you want to remember, in the pulp and paper industry, a lot of the defaults here are AFLAS and EPR. There's other names those are generic names for the types of O-rings, but there's EDPM is another variation of the EPR O-ring. Single seals with hard faces and steam quenches have been used. So basically, the you know, like a bellows, single bellows seal, especially if it's a small envelope where the pump can actually fit it inside the pump. You can run a bellows seal with a steam quench. You have plenty of steam available in a pulp in a pulp plant. Steam costs money though, and that's one thing that if you're doing any studies to see how much energy you're spending to make steam, you'd be surprised how much you can save by eliminating certain steaming processes, especially like if it's just cleaning a mechanical seal. If you could go away from a steam process to a barrier fluid process in a mechanical seal, you may save. It may pay for itself in the course of a couple of years. So some things to be, to look at when you're analyzing your system. A dual seal is more money than a single seal, but in the long run, where's the rate of return? If these pumps should shut down, they should be steamed to prevent the black liquor from setting up. As you probably all know, what black liquor looks like and can do when it gets to higher concentrations. Now, heavy or strong black liquor, this is higher than 50%. Dual seals with hard phrases, okay? Cold water will allow this black liquor to harden. Look for warm water saucers for the barrier. Again, this stuff it's tarry, it's nasty looking. The ISC2, again, with a dual system with a warm water source, and of course the bellows are preferred. And the pumps, it'd be nice if you had the tapered bore or large bore. You want to definitely steam out the stuffing box after shutdown prior to startups to help to make sure that the black liquor has not set up, and of course destroy the mechanical seal right at startup. So those are some important things to remember. Sealing green liquor. Okay, dual seals preferred. Sizes tend to be larger than 3 inches on this type of process. The ISC2, they make the ISC2 mechanical seal up to, I think, over 6 inches. On the I think anything after that, I think they can go up to 8 with specific engineering applications. Again, AFLAS O-rings, and of course EPR on the BX seals have been used successfully in the pumps and agitators. Pressurized water barrier is typical. Single cartridge BXs have been used with external seal flushes on this. This stuff can get very abrasive. Now, of course, this is where the slurry seals come in. That would be the ones that would be the SLM and the SLC seals that we talked about. The ones with the very robust end-facing mechanical seal designs. They've worked very well in these types of applications. Sealing white liquor. Now, lime is then added to the green liquor and forms the white liquor. Prior to the clarifier, the white liquor is very abrasive, requiring hard faces on dual seals or the use of the single seal with a throat bushing and external flush into the stuffing boxes. Okay, so that would require, of course, a water source that you would then keep the mechanical seal flushed with a Plan 32. Again, you're bringing water into your service, so those are things that you'd have to worry about managing. Abrasives are very hard on mechanical seals. Certain types of mechanical seals will hold up in certain fashions. Generally, what you see with typical mechanical seals that have standard configurations, some of the lower-end mechanical seals, which are typical to have the springs on the rotating sleeve inside the process. When dealing with the abrasives, what you'll see happen is these dirt and particulates will actually build up inside the springs themselves and eventually plug it off and hang up. Other lower quality seals, if you don't have the proper metallurgy or the metal quality isn't that great, the abrasives will literally eat the seal apart, and within a short period of time, you'll have a failure, you'll take it out, and the seal is completely shot and completely wasted. That's one of the things where the design factor in like the slurry seals and how they're actually laid out is very, very important to compare when looking at different types of sealing options. Some of the places where they've had, we've had successes. They have used the ISC2 in certain certain lower abrasive levels with Plan 32s with hard face combinations. But primarily, the bellows seals will work because they don't have a dynamic O-ring. However, the bellows themselves, they're very, very thin. So if you're constantly washing, and of course they are on the rotating side of the seal, and you want them on the rotating side of the seal when you have a dirty surface, so that the bellows can self-clean as they spin, because it'll throw the debris away from the actual peaks and the actual valleys of the bellow itself. But the bellows are very thin. Over time, it's like running sandpaper over them. So on the peaks where the actual bellows metal is welded together, I've actually seen it where they've sanded themselves off and they actually come apart. It looks like a slinky when you pull on it. And it's due primarily with abrasives. The most unique one I saw was the abrasives were quartz in a flour consistency, so they were less than 5 microns fine. So if you looked at it, this quartz was actually like a powder mixed in with a viscous fluid, and would, even in a Plan 13 configuration where you're actually flushing from the mechanical seal back to the suction process, which generally helps you with dirty surfaces, it would still erode the seal gland in about 6 months. And we're talking about shaft speeds of around 3,600 RPMs. Very, very interesting thing to see, but remember that bellows are thin, and they can erode away. And again, this is where the SLM really can shine, and these seals take. And the SLM, for instance, can, you can have abrasives up into the 40% range, I believe, has an upper limit, and it will work just fine. The SLM seals and the slurry seals work, any type of heavy abrasive surfaces. This is when you want to start looking at them. They're heavier. They don't fit in every configuration. I mean, they were designed specifically to go into slurry-style pumps. They're also limited on the speed because they are heavy and robust, and the faces are wider. You have to be careful in the amount of the speed that they actually are spinning at. I think the surface speeds of an SLM are limited to, I believe, 75 feet per second, and an SLC, which is even higher, they're limited to, I think, 50 feet per second. So depending on how big your shaft size is and how fast the pump's spinning, that limits your actual seal speed. Again, the abrasives also create heat, and that's the big factor that's slowing you down, is the amount of heat generation that you can handle. And applying slurry seals and looking at slurries as opposed to fluids, there are certain things that you have to take into consideration because they don't act the same. Once again, of course, your elastomers, of course, are AFLAS and EPR. Okay, the bleach plant. Well, as you know, your bleaches they're chlorine, chlorine dioxide, sodium hyperchlorate. These things, of course, if you look at any metallurgical chart, basically there are 2 things that can be used in these surfaces, and that's titanium or Hastelloy. I don't even think Monel is Monel or even duplex stainless steels will pass muster. I'm almost positive that a stainless steel won't pass muster in chlorine surfaces because I think the chlorines directly attack them. But basically, so with the wetted parts, you're looking at fairly expensive mechanical seals. So what you want to do when you're doing this application is you want to make sure you got everything right. And of course, you want to make sure that there's nothing's going on in the material selection when you're buying a mechanical seal. You want to have silicon carbide versus silicon carbide inboard faces, so you want to make sure you have a hard face combination. You also want to make sure that you're using dual seals in these types of applications. But again, because the chlorine, just when it gets to the outside, it kind of salts up and leaves a residue, so you have to manage that as well. And it's a caustic, and it can cause, if it gets on anything, you don't want anybody to breathe it. It can cause to make someone sick. Again, here on the elastomers, pretty much you're limited to the CalRes family or the ChemRes, which is CalRes is a DuPont product and ChemRes is a Green Tweed product. These elastomers are basically competitive brands, but they make an O-ring that can pretty much take any type of chemical environment that you can throw at it, and it'll withstand it. ChemRes and CalRes O-rings, you're talking a substantial increase in price over standard, let's say, nitrile or Viton O-rings. That's probably 3, 4, sometimes 5 times the expense of the O-ring. It's amazing how quickly these things how pricey they can get. The IC2 seals, they have they can make the IC2 in Hastelloy. And again, with a water barrier, the IC2 is a general serve industry seal, so its specifications were for chemical plants. So yes, they do make this they do make it, and it is standard dimensions. Expensive, but you have since it is standard dimensions outside of the materials, it can be made in both Hastelloy and titanium. And of course, caustic sodas, sodium hydroxide. Dual seals are preferred. Single seals with hard faces and steam quenches can also be used, but again, we talked about steam being an expense. And of course, you want to use your AFLAS and EPR O-rings here. Okay, sealing the additives and agents. Okay, these coatings, filler pigments, they can be abrasive. You want to make sure you're using your slurry. You want to make sure you're using slurry seals. So, like I was talking about, the SLC, and the SLM. The RIS, which is sometimes referred to as a RIS seal, is a rubber-energized spring. And instead of having a traditional spring that pushes on the seal faces, this has a rubber boot that pushes on the seal faces. Again, I didn't include it in there because I've had the most experience and success with the SLCs and the SLMs. Haven't really had too much. Not that it's not a successful seal, it's just that I don't have much experience with it, so I didn't put it in there. But it is worth mentioning that it is another type of mechanical seal that can be used in abrasive services. Starches, resins, and dyes. Dual seals with pressurized water barrier preferred. Sizing agents, other additives, depending on the chemical, but typically dual seals with pressurized water barrier systems. And these, like I said, you may see in some of these applications that you're not using them. You may be actually using, in certain things, you may actually be using packing in some of these more abrasive type areas. What we're suggesting is if you wanted the most reliable, robust type of system, we would recommend these dual seals, and that's kind of where we're coming from. They can be very we want to increase your reliability, and we don't want the downtime. Unlike refineries and chemical plants, they have lots of spared equipment. From what I've found is that most of your pulp and paper plants, they don't have spared equipment. So when something goes down, it's let's get it back up right now. Well, when you have a process like that, you want to make sure that you have you don't want downtime. And if it is down, you want to be able to turn it around as quickly as possible. So that's some of the reasons why we're talking a lot about the dual seals. And of course, on some of the positive displacement pumps, they make a lip seal, which works well with viscous surfaces, but there are other types of even packing. Once you get to very, very viscous properties with your pump fluid, mechanical seals just won't work well without some sort of barrier fluid. It just won't. You have too much viscous shear between the faces, and it just comes apart. And of course, sealing the paper stock. The chest vessels and agitators, again here the MSS, that's the split mechanical seal. The PSS III, which is a split, or the MSS is a split mixer seal. The PSS III is a split mechanical seal. Can be used on both pumps and in certain mixer arrangements, especially if it's wetted with a side entry. They can also be, again, you want to have small volumes of flush water. in the pulp in the paper stock pumps, of course, with the larger sizes, you want to have, you could use the PSS III Split Seal if it requires a lot of time to take the pump down and disassemble it to replace the seal. Again, if time is of the essence, a split seal can be put in fairly quickly, as opposed to disassembling the whole pump and putting a brand new cartridge seal in. If you do have spares, of course, an ISC2 mechanical seal is an excellent choice in some of the more general services, if configured correctly. Again, you want to make sure you have small amounts of flush water to keep the paper stock away. The paper stock can get, it dries out, it draws water out. So when it dries, it starts to get very abrasive, especially in the stuffing box. If no flush is allowed, if you don't want, you want to eliminate all that water. Again, you would want some of the SLCs, the wrist seal. They have, some people have said the BX seal will work. It does work it does, because it won't hang up. It is an acceptable thing. But again, you want to be careful on just how abrasive your service is before applying a bellows seal. Again, they don't have a dynamic O-ring, so they don't hang up. But the bellows themselves, they are thin, and if it's too abrasive, it can actually wear out depending on the type of material, it can actually wear out lots of dirt and fine particles can wear out the bellows itself. And of course, the SLM with a water barrier fluid, that also helps. Now, in the powerhouse side of things, the boiler services, the boiler feed services, condensate waters. The D seal, like we first mentioned, that's the workhorse. Used a lot for large boiler feed water pumps, and I'm talking about the multi-stage centerline splits, even some barrel pumps. Those are where you see the big D seals, and even in some dual high heat seals. If your plant's not to that level where you have these very, very large boiler feed pumps, the D seal is because it's it's an expensive seal, so and it won't really fit in smaller applications. So if you're borderline, if you're only pumping 250 degrees in some of your applications, you probably don't have a center line or a split line pump. You're probably not. You wouldn't have a seal chamber large enough to really handle a D seal. You'd have to go back down to maybe some of the QB seals, the QB lube groove type of seal, especially if it's standalone. If you have a water or for lime slurries and ashes, again, the slurry seals, the SLC, the SLM, and again even the RIS seal. They have water-saving capabilities by using these types of seals, especially in the like I said, with the lime slurries. You can use the other types of seals that we can use, and these are very robust designs. In the smaller ANSI applications, where you're basically not as hot as some of these pumps can actually handle. Say you're in the 230 or 250 degree range. An ISC2, a standard pusher mechanical seal with a pumping ring, can be used with a Plan 23 cooler system, and that will get you a nice long lifetime out of it, and it'll fix a lot of problems that you have with standard mechanical seals and high heat services. Because if you're just using a simple component seal or even a simple cartridge seal design from any manufacturer that's really not designed for boilers for hot water, if it's just a standard mechanical seal, you're probably making a couple of years. I've actually heard of the anomaly of someone saying, nope, I've gotten years out of it and I don't do anything, and it's pushing hot water at this temperature. Now, there might be pressure differentials. The pressure gradient might be good enough in your stuffing box to where you're not flashing. If that's the case, then you might actually have enough of a fluid film. The other thing you also have to remember is if it's running and you're not seeing any leakage, doesn't mean it's not necessarily leaking. Whatever's coming off might actually be off-gassing and steaming itself away. But again, I would say 90% of the time, if you don't have a properly set up mechanical seal in a hot water service, it's probably not going to last you that long. Again, the general service pumps, the ANSI pumps, any of this, you know, the under 300 psi, under 300 degrees Fahrenheit. These are where your ISC2 seals are used. Just moving stuff all up, you know, from here to there, you know, up to, you know, maybe up to 4-inch, even 6-inch line size pumps. And again, for large applications, big mixers, big vertical pumps, the PSS III Split Seal can come in very handy if downtimes are an issue. It's a good alternative for packing. Split seals they install very, like I said, they install very quick. The only thing you got to really realize with a split seal is you're putting together two mechanical seals. And the flatnesses, and we talked about how flat a mechanical seal is. So when you're bringing these two parts together, it's very, you have to pay very close attention to it, and you also have to understand that there may be leakage. You're probably going to see a drip. You know, there's a 50-50 shot that there's a drip afterwards that may be there for the whole duration of the run. Some of the accessories that you want to look at in the mill and the pulp and paper mill applications, of course, seal guards for flush regulation to make sure you control the flow, and that's in like Plan 54s. Seal coolers used for Plan 23s. For longer seal life, of course, you want the bearing guards are another product that will actually keeps the power frame, keeps the bearings dry and out of the process. And of course the SLD, now that's the automatic greaser, that goes in with the slurry seals. In conclusion, carefully consider the seal, auxiliary features, and flush plans. Those are the things that no matter what you're doing, what you're looking at in your plant. Standard seals are available for most of these services. Heavy-duty seals are available, just like we talked about. They require some engineering review. Paper stock can dewater and become abrasive in a conventional stuffing box if no flush is provided. Sealing pulp and paper mill applications utilize the same logic as you would in any other type of industry. So when sealing the products, you need to think about, if you came from another industry, when you were dealing with things that set up, things that harden, things that crystallized, and produced slurries, the same types of logic is applied. So those are some of the things that you can come into when dealing with pulp and paper applications. If you have any questions, we can try. I try my best to try to answer at the end of the seminars using the diagonal pop-up box that's here. But if you have if I have some miscommunication as to that, you can always call me or email me. Again, here's my email address right in front of you at Frank Rotello at Siewert Equipment, or you can call the 1-800 direct number. They'll be able to patch you into me. If you'd like a site visit, one of the things I've actually neglected to say in the past presentations is if you would like me to come to your site and talk to you a little bit more about this, or even offer some training sessions to your staff, please give me a call, and I'll be more than happy to do that. And I'm going to click over now to see if I have any questions. Where's my questions? Okay, and there's actually, I've got 7 attendees. I think everybody's, some are dropping off. I'm going to see if I can go. Since I only have 6 attendees, I think I might try to unmute you and see if there's any. Yeah, here we go. Yeah, if anybody would like to talk directly to me, I have you all unmuted. You're more than welcome to say something. Okay. Well, if no questions, everyone, thank you very much for attending. Have a good and safe, productive work week, and we'll see you at the next one. Have a good day.